If I were to pick one thing that we are doing in this course that will be most like something that you are doing in your next course, it would have to be standard deviation, okay? I just love pop-ups. All right. So today we're going to talk about standard deviation. The last time we were together, we were doing box plots, box and whisker graphs, 5-number summary, and we were talking about the amount of spread in the data or the amount of variation from small numbers to bigger numbers, and where was there more spread. And I mentioned to you at that time that we are definitely going to be getting a way of measuring spread or the amount of variation in the data, okay? Like for instance, if this is your data, compare the amount of spread here to the amount of spread here. There's no comparison. Here it goes from a small number of 1 to a large number of 5. Here it goes from 1 to 24, for heaven's sakes. Much, much, much more spread over here, or variation. You would expect the measure would give you a larger number for the spread here than it does here. That measure of spread we are going to call standard deviation. Okay, the standard deviation. You will use in almost every class period in Introduction to Statistics, you will use the standard deviation of your data. Okay, it is that important. So we're going to talk about how you can find the standard deviation, the amount of spread for your data. I've got it summarized here in 5 steps. Also, many of the calculators that you are using, you can find standard deviation on your calculator. For our purposes here, I want you to understand how this is done. I'm going to be looking for the work, all right? If you want to learn how to do it on your calculator in preparation for taking stat, I think that's a great idea. And come to me sometime and we'll discuss it. And I'll show you how to do it on your calculator. And you can even do it and check your work here in the second part of our course. But make sure on your homework for this particular lesson, you show me the work here so I can give you credit on your homework. All right. So we are going to find standard deviation today. That's how easy this is going to be. Once you get onto the steps, you will not have any trouble whatsoever. Okay, so the first thing we need to do is find the mean. For 2, 6, 8, 9, and 10, we've got to add those up. That's 8 and 8 is 16, plus 9 is 25, plus 10 is 35 divided by 5. The mean, or x bar, should be 7. Okay, let me double check that again. 8 and 8 is 16, yep, and divided by 5 is 7. All right, for each data point. Now what I like to do is make a little chart. So we have our data, our x values right here, okay? So we have 2, 6, 8, 9, and 10. Then we have x bar, which is 7, 7, 7, 7, 7. Now, I want to find the square of the distance to the mean. So I want to take the distance from the mean, the distance. So I want to take x minus x bar, and I want to square it, okay? Why do you square it? When you take 2 minus 7, you get a negative number. If you square it, it makes it positive, and everything will work out to be positive that way. By the way, it does really not matter how you subtract. If you want to avoid getting the negative number, you can take 7 minus 2, because when you square it, it turns out to be positive anyway. Remember, a negative times a negative is positive. So 7 minus 2 is 5, square it is 25. 7 minus 6 is 1, squared is 1. 8 minus 7 is 1, squared is 1. 9 minus 7 is 2, squared is 4. 10 minus 7 is 3, square it is 9. Everybody with me? Okay? Add up these values. So I need to add these up. There's 13, 14, 15, and 25 makes 40. Okay? Divide by the number of data. There are 5 data. And then take the square root. Okay, so that should be 8. 40 divided by 5 is 8. I think the square root is 2.828. Let me double check that. Square root of 8 is 2.828, right. There we are. That is the standard deviation. That is the measure of the amount of variation in this data, 2.828. Okay? Let's do another one. Okay, number 2. 1, 2, 3, 4, 5, 6. How about that? Find the standard deviation of 1, 2, 3, 4, 5, 6. I must first find the mean. You can almost guess what the mean is going to be here. If you just look at the data and think about it, you should be able to guess. But anyway, let's add them up. 3 and 3 is 6, plus 4 is 10, plus 11 is 21, divided by 6 is 3.5, which you may have guessed. The middle here is 3.5. All right, so I know that X bar is 3.5. Make a column for the data, for the X bar, and I want X minus X bar squared. All right, so my data. The X bar is 3.5 in each case. I hope I'm not writing too small. Can you all see that? I think it's pretty good. All right, 3.5 minus 1 is 2.5. Square that is 6.25. 3.5 minus 2 is 1.5. Square 2.25. I have some of those memorized. 3 minus 3.5 is 0.5. Square it is 0.25. Same thing here. It's 0.5. It's 0.25. 1.5 in each, 1 for 5. Anyway, 1.5 squared is 2.25. And this one is 2.5, which is the 6.25. Okay, let's add them up. 6 1/4 plus 2 1/4 would be 8 1/2. Plus 1/2 is 9. Plus 8 1/2 is 17 1/2, I think. Let me just double check that. 6 1/4 and 2 1/4 is 8.5 plus 1/2 plus 2.25 plus 6.25, and I get 17 1/2, correct. All right, now we have to divide by how many data items? 6, and take the square root. Okay, so I'm going to divide by 6 equals, and take the square root, and I get 1.708 is the standard deviation for that particular set of data. Okay, that's all there is to it. One more. Find a standard deviation of this set. Okay, this one's not going to be quite as easy. So let's add these up and find the mean first. 10 and 12 is 22, plus 18 and 21 is 39, plus 24 and 27 is 51, plus 30 is 142 divided by 7. I get X bar is 20.29. Yikes. This is going to be ugly. All right, so I have the X column, the X bar, the X minus X bar, 20 squared. Okay, so here I go. My data column is 10, 12, 18, 21, 24, 27, and 30. Are there 7 of those? Yeah. X bar is 20.29 for each of these. Okay, so here we go. I'm going to subtract this minus this is 10.29, and I'm going to square it. So 10.29 squared plus, maybe I better do them all. This is 105.88. 20.29 minus 12 is 8.29, I think. So 8.29 squared is 68.72. 20.29 minus 18 is 2.29 squared is 5.24. 21 minus 20.29 is 0.71 squared is 0.50. 24 minus 20.29 is 3.71, I think. Squared is 13.76. 27 minus 20.29 is 6.71. Squared is 45.02. 1, 2, 3, 4, 5, 6. One more. 30 minus 20.29 is 9.71. Squared is 94.28. So now I got to add these up. Plus 45.02 plus 13.76 plus 0.5 plus 5.24 plus 68.72 plus 105.88 equals 333.40. Now, just to double check my work, I'm going to go down through, subtract and square it, and just double check my work. This minus this is 10.29 squared plus 8.29 squared plus that minus 18 is 1.71 squared plus that minus that is just 0.71 squared. That minus that is 3.71 squared. That minus that is 6.71 squared. And this minus this is 9.71 squared. Equals, and I'm off a little bit. This one up here bugged me a little bit. Did I do it correct? 20.29 minus 18 should be 1.71 squared. 331, I get 331.11. And I think I messed that one up. 20.29 minus 18 should be 1.71 squared. 1.71 squared, aha! This should be 2.92, and that's where my error is. 2.92. So, my answer is 331.11 divided by your number of data, 7, and take the square root. So 331.11 divided by 7, and take the square root of your answer, and I get 6.88, which is the standard deviation, okay? So that is how you find standard deviation, and hopefully you don't mess up in your calculations like I did. Number 4, which set should have the larger standard deviation? You can see this one has a spread from 4 to 11. There's 6 items of data. It's spread out over 7 units. This one only goes from 11 to 15, which has 6 items of data, and it's only spread out over 4 items, okay? This one should have the larger standard deviation. How about number 5? Which set should have the larger standard deviation? This goes from 6 to 13. There are 6 items of data. 6 to 13 has a spread of 7. This one goes from 1 to 18, a spread of 17. Even though there's only 5 items of data, ordinarily, if they were closer, I'd want to do both of them and check. But because of the spread of that one is so big, at 17, we can rest assured that that is going to be the one with the larger standard deviation. Okay? So, standard deviation is what we're thinking about today. We're going to soon get into z-scores as we wrap up our study on statistics.